Swayam Prabha. Digital India. Educated India.
Now another point I wish to make is that, you frequently hear statements like no DC can go through a capacitor and so on. Okay. Now this can sometimes get very confusing, because what if I make a circuit like this? Let's say this is a 1 milliamp current, a constant current, and I just connect it to a capacitor. So clearly by Kirchhoff's current law, this current has to be flowing through a capacitor. And so what happened to this statement that a DC cannot flow through a capacitor? Here a DC is very much flowing through a capacitor. So these statements like capacitor blocks DC or DC cannot flow through a capacitor, this has to be stated a little more precisely. Now that will be apparent if you examine the voltage here. What happens to the voltage? Because the current is a constant, the voltage will be a ramp. Okay. So if this current is some I naught, then Vc versus T will be a ramp, and whose slope is I naught divided by C. Okay. So the point is, the input is a constant with time, but this response Vc is continuously changing with time, and this will never stop. You can see that even if you go all the way to t equals infinity, this will simply keep on growing. Okay. So the reality is that a circuit like this does not reach steady state. Okay. Or in other words, the natural response does not die out. And this is not surprising, because if you try to evaluate the time constant of this, you set the source to 0, the independent sources to 0, and in that case you will be left only with the capacitor and an open circuit. Okay. You can think of it as an R which is infinity. We have earlier discussed that an open circuit is equivalent to an infinitely large resistance. So the time constant tau, which is RC, is also infinity. The time constant is infinitely long, so that means that this simply does not reach steady state at all. Okay. So it is possible for DC to be flowing through a capacitor, but such a circuit will not reach steady state. Rather, more precisely, what I should be saying is the following. In a stable circuit with constant inputs, that means that the independent sources in the circuit have a constant value. Then in steady state, this is very important, capacitor voltages are constant with time. Okay. And exactly the same also holds for inductor currents. So this means in turn that because the current is the time derivative of the voltage in a capacitor, capacitor currents are 0. Okay. This, by the way, we have been looking at first order circuits, but these statements are true for circuits of any order. So if you have constant inputs and the circuit is stable so that its natural responses die out, then after it reaches steady state, the capacitor voltages will be constant with time and the capacitor currents will be 0. And exactly the same thing will be true of inductor currents. Inductor currents will be constant with time and inductor voltages are 0. Okay. So the important thing is, for this to happen, many conditions need to be satisfied. You need to be having a circuit with a constant input, and the circuit must reach steady state. That is, the circuit must be stable so that it reaches steady state in some time. So after it reaches steady state, then you won't have either a DC current through a capacitor or a DC voltage across an inductor. Okay. So this, please understand the conditions. Otherwise, I can easily cook up some silly looking example like this, where DC is clearly flowing through the capacitor. But the point is, this is not a stable circuit and it does not reach steady state. Okay.